Welcome back, everybody. We are talking about exponential functions again. This time we are going to be looking at some word problems that have exponential functions involved and try to figure out what the function is representing and how to solve for pieces of information. So just a quick reminder, we are typically going to see our exponential equations say y equals a b to the power of x, and you're probably going to see that b inside of parentheses. If we ever use other letters instead of x and y, for example, this next one we use c and t, that's fine. It's still x and y. We're just using variables to represent real life situations and tangible things like money, time, all of that. So don't get confused. Y is still y, x is still x, even in these problems. So here we have the function c is equal to 179, parentheses 1.029 to the power of t. This models the amount of soda consumed in the world, where C is the amount consumed in billions of liters, and T is the number of years since 2000. A very important number of years since 2000. So if we are talking about the year 2015, it has been 15 years since 2000, so your T would be 15. So what we want to do first is find and interpret what the y-intercept is. So we're going to graph it. But your graph, you're not going to be able to see it. So we are going to look at the table for when x is equal to 0. That'll help us find the y-intercept. So when we put this into our calculator and look at the table, when x is equal to 0, y is equal to 179. So our y-intercept is 179, which that means no time has passed. So it is the year 2000. So in the year 2000, we consumed 179 billion liters of soda. That is what our y-intercept is representing. It's like the starting place for soda, how much soda we have. Now, part 2 of this question is asking us to find out how much soda was consumed in 2005. If our initial year is 2000 and it's now 2005, our T for years is 5 years. So we're going to take the formula. Again, it should still be in your calculator if you looked at the y-intercept. And we're just looking at the table and finding the value for x when x is 5 to see what y is. So you can look at the table or plug in x is 5 for the equation and see what it gets to. And we get 206.5 billion liters of soda. A lot of soda, y'all. Looking at the next example. It tells us here the function v equals 25,000 times 0.82t models the depreciation of the value of a new car that originally cost $25,000. So what you may not know is that when you buy a brand new car, as soon as you drive it off the lot, the value of the car diminishes greatly. And so this kind of shows that, maybe it's been 5 years since you purchased that car, what your car is now actually worth, and it's a lot less than what you originally paid for it. So for this example, the rate is 0.082% or 0.082 with the original cost of $25,000. So V represents the value of the car, T represents the time in years from the time the car was purchased. So it wants us to know what is the value of the car after 5 years. So that means T is equal to 5, and we plug that into our equation. 25,000. Make sure you get enough zeros in there. 0.82 to the power of 5. So you can type this into your calculator and solve, or you can graph it and look at the table. It does not matter to me. When you calculate this, it tells you your car is currently worth, or is worth after 5 years, $9,268.50. So you went in 5 years from $25,000 to less than $10,000. So dramatic drop. Our next question says, how many years until the car is worth about $5,000? Now here's where I would put it into a table, because it's not going to be exactly $5,000. It's going to be a number close to $5,000. And so you're looking for where exactly does that happen. So scroll through your table, looking at the Y values, and see which ones, are close to 5,000. So as I scroll through on my calculator, I notice that at 9 years, at 8 years, it's $5,100. And at 9 years, it's like $4,100. So I'm going to say 8 to 9 years, because it's going to be somewhere in that range of 8 to 9 years that it's about $5,000.